An EC fan does not become precise simply because a controller is attached. Its behavior starts in the stator slots, copper path, insulation, rotor air gap, connections, and final test. Miss one link, and the controller may only manage an inconsistent motor. Think of EC motor manufacturing as one closed chain. Core geometry guides the winding. Copper creates the magnetic field. Insulation protects the electrical boundary. The rotor converts the rotating field into torque. Electronics commutate the phases. Assembly preserves alignment and heat flow. Testing closes the chain. The stator core and slots must match the approved design. Edge condition, slot protection and dimensions matter because the winding must sit where the electromagnetic model expects it. Footage shows the station, the drawing and inspection record define acceptance. Wire size, turn count and phase distribution are product specific, but consistency is essential. Uneven placement can change resistance, heat distribution and magnetic balance. Control the winding program, tension, routing and termination, then link the result to the unit or lot. Enamel alone is not the insulation system. Slot liners, phase barriers, lead routing, winding retention and termination protection must work together. Required dielectric and insulation checks depend on the motor design and approved test plan. Visual inspection cannot replace them. In a brushless permanent magnet topology, the rotor follows the electronically sequenced stator field. Magnet placement, retention, concentricity and air gap shape that relationship. Rotor construction varies, so its controls belong to the product drawing and validated process. The controller replaces mechanical commutation with electronics and logic. Depending on the architecture, it conditions the input, drives phase switches, reads position sensors or estimates position, and applies protection. Layout, components, firmware, and thermal design form one control system. A populated board is not finished because every component is present. Connector seating, soldered connections, strain relief, clearance, cleanliness, and thermal interfaces need defined workmanship criteria. The applicable class and process standard come from customer and product requirements. When stator, rotor, bearings, shaft, controller, and housing come together, stack-up becomes performance. Alignment, routing, insulation clearance, fastening, balance, and heat paths must survive the sequence. The goal is to preserve design intent, not merely fit the parts. End-of-line testing should answer specification risks. It may include winding continuity or resistance, an applicable insulation test, rotation direction, speed, current, control response, sound or vibration. Limits and methods must be defined for the actual motor and fan assembly. Manufacturing evidence connects material lot, winding program, process station, controller lot or firmware, assembly status and test result to a serial or batch. Engineering can then investigate variation without guessing which version, process or result belongs to the unit. Motor winding and EC controller assembly should work as one controlled electromagnetic chain. Prepare the stator, place and protect the copper, control the rotor relationship, assemble the electronics and mechanics, then verify the finished function.